All right, everyone. So in the last video, I introduced the idea of different types of bonds and also electronegativity. Now I just want to do a quick review of those types of bonds and show you how we do those differences in a couple practice problems. So just to review, when atoms interact, it's really the valence electrons that are interacting with one another. So these interactions can either be a function of stealing or giving up. And if that's the case, where one or more valence electrons is stolen from another atom, we call that an ionic bond. However, in some instances, one atom might not be strong enough to fully steal an electron from another atom. So in that regard, they can share, and we call that a covalent bond. Co as a prefix means together. So think of it as sharing valence electrons. And if there's not really a huge difference, as we learned in electronegativity, then that yields nonpolar covalent, because they have to roughly share equally. But if one is slightly stronger, then it can create what we call a polar covalent bond. And that is all calculated by the difference in value between electronegativities. So if it's really small, again, nonpolar covalent. If it's in between, they still have to share, but it might create poles, so a slightly positive side and a slightly negative side. And then if it's really large, then it becomes ionic. So to kind of review what the different properties of compounds can be, ionics kind of fall into what's on the left. This is when you have a metal and a nonmetal. And I'll review why that is in a minute. Most of the time, these things are solids or salts. For example, sodium chloride is table salt, and it has sodium from the left side, which is a metal, and chlorine, which is a nonmetal from the right side. Typically, these things dissolve in water and really other polar substances, and they oftentimes have a high melting point. And the reason that is because ionic bonds are really strong. And so it takes a lot of energy, in this case heat, to break those bonds. Now, covalent on the right-hand side is a little bit different. This, again, is the sharing of electrons. So oftentimes they are a gas or a liquid at room temperature. What should also be added here is that it is two nonmetals together. So two nonmetals combined. And that roughly translates to two things from the right side of the periodic table, on the right side of that imaginary ladder that we have. They don't dissolve in water, and because the bonds are a little less strong, they have a lower melting point. It takes less energy to cause them to melt and also to boil. So let's just kind of go through a couple of practice problems to get you reacquainted with how we categorize these. Let me just turn on my little friend here. So first up, we have calcium and chlorine. So calcium is right here on the left in the second column, and chlorine is over here on the right in the seventh column, so to speak. So to figure out the difference here, you just subtract. So I'd end up taking 3 minus 1. And if there was a decimal, you can include it. But it ends up being 2. And if you refer to the chart that we had, anything over 1.6 is ionic. So this is an example of an ionic bond. And it's got something from the left and something from the right. And again, the imaginary staircase that lives on the periodic table, you can kind of see based on the colors there. But that's roughly what it looks like. So anything on the right side of the ladder over here is considered a nonmetal, and anything on the left side is considered a metal. Hydrogen and hydrogen, well, that's easy. It's the same element. So regardless, when you have the same element and subtract itself, you're going to end up with 0. So if I kind of go back to number 1, this is an example of ionic because it is a large number. This would be considered nonpolar covalent because they're sharing and it's such a low number. The last one is nitrogen and oxygen. You can see that they're right next to each other on the right-hand side, and there is a slight difference. So you'd end up doing 3.5 minus 3. So you'd end up with a small value that's not, nothing. It is a specific value that's a little bit more than 0. I think the range is 0.4 to 1.5. So this would be considered polar covalent because there is a slight difference in charge.